So today's problem is range sum query immutable. This is a very easy question, and you can see the like dislike ratio is not too happy, but we're going to discuss two solutions for it. One of them takes order of n time and the other takes order of 1. Both of them are extremely simple and rely on simple basic concepts. The first solution says do exactly as the question asks you. Okay, the question is really about this sum range. Sum range basically asks you to return an integer. Now this integer is something you derive from the sum of the elements inside of nums from left to the right. So left and right inside of this length of this list nums, left and right are two markers saying that from left to right, both inclusive, I want the sum of elements in between. And so this is exactly what we can implement, exactly as the question says. We'll have the nums here, and then now, what do we want to do here? We want to return what? The sum of what? Sum of self.nums from left to right. Now, be careful, this is not exactly right, but right plus 1 because of the way list slicing works in Python. And this is pretty much it. We'll just submit it right away and look at the runtime here, which is going to be the one of the important metrics. The runtime is almost 1 second, and we can improve that by a lot, because let's discuss the space and time complexities. So in this init function, what's happening? We're just storing whatever the nums there are. No extra space or time taken, order of 1 both. Okay, what about sum range? Well, in this case was the worst possible thing that could happen. From left to right, you're taking the sort of sum of all of the elements in between. Was the worst possible case? Left is 0 and right is all the way up to 9. And if there are multiple such queries, you'll just take order of n time each iteration, n being the size of nums. Can we do better? We can do a lot better. In fact, we can reduce this order of n time complexity to order of 1. Again, this is going to be very simple, and we're just going to use cumulative sum instead. And in Python, you can do so by using accumulate. Accumulate lets you input a list, and will also specify initial equals to 0. It says that this list is something that you have to cumulatively add on each element, but also start with 0. We'll talk about why that is in a second. And we have the accumulate here. Now, because of the way, again, Python is lazy, we're going to convert this into a list. Don't worry too much about what it means to be lazy. Okay. Once we have this cumulative sum stored, what can we do? It's again very simple. We've stored it in self.nums itself, so no extra space taken. And we're going to have self.nums here, and we're going to access the right element, again right plus 1 because of indexing, and we'll subtract it from self.nums of left. Okay, this is the entire solution exactly, and we're going to discuss why this works just in a second. But look at the runtime differences. It's 1 second and it's just 64 milliseconds. Again, that's because you reduced the space-time complexities to order of 1 both. Now, why does this work? It's a very simple idea. See, let's take the case of nums as 3, 2, minus 9, and 5. Okay, this is our nums. What happens when we do a cumulative sum? Okay. By the way, I'll also mark indices. So let's have nums as this, and we'll say indices. This will be 0, this will be 1, and 2, and 3. Simple. Okay. What about cumulative sum? We're starting off from 0, as we mentioned here in the initial one. And then we'll look at 3, we'll add it to the previous element 0, and we'll have 3. We'll look at 2, we add it to the previous element 3, and now we have 5. Then minus 9 looks at 5, we have minus 4. Then 5 looks at minus 4, adds, and 1 is the answer. Okay, so this is the cumulative sum array. How can we make use of this here? And why does this work? It works because let's say we have a query now of I want a range from say 0 to 2. Okay, we'll look at the exact number here. 0 to 2 is 3, 2 and 9 minus 9. Was the sum? Minus 4. Keep that in mind. Okay, the sum is minus 4. And we should be able to find that out inside of this array in order of one time. Instead of adding 3, 2 and minus 9 together, we can just look at this element, minus 4, and we'll look at this element, and that will get us the answer. You see how that works now? See, in this case, what was happening? Right was 2, left was 0. Now right plus 1 pointed to this element, minus 4. From minus 4, what did we subtract? Left, which is 0. So minus 4 minus 0 is minus 4, and we have the answer here. Take for example the case of, say it's 2 to 3, or actually 1 to 3. How can we find the answer in order of one time? We just follow this formula. Nums of right plus 1. What is it going to be in this case? It's going to be 1 here. So we'll have 1. Right plus 1 points to one element, and then left points to left is 1, so we'll have 0, 1 as 3. So this should give us a sum of negative 2. Let's check it out in the original array. So we have 0, 1, 2, 3. We want the sum of all of these. Minus 2, minus 9 and 5. What does that give us? Minus 2. And so you were just able to look at this array, 2 elements inside of this array, taking order of 2 or equivalently order of 1 time to do the computation. And then that was able to give you the answer for the entire thing. Okay, pretty simple question, pretty simple solution. But there is another solution that exists, which is a bit more interesting. However, not really the best for this question. In fact, the other solution or the other approach is to use segment trees. If you are familiar with that concept, well, I don't think you'll need to watch this video. I don't know what you're doing here, but you can look at my own implementation of segment tree for this question. Links in the description below. Just to show the differences, this is our order of one time complexity solution. This is the order of n time complexity solution. The tree one, the segment tree, actually takes 256 milliseconds, which is order of log n time complexity. If you're interested, again, links in the description, check out my writer. Anyways, that is it for the solution of range sum query immutable. Pretty easy question, pretty easy solution. That's it. Thanks for watching.